Because as my brother rightly said, I am the one taking this course with him, applied electricity, DB151. But today, the course outline, or what we are going to be talking about today is resistors in parallel and resistors in series. And also, if time permits us, we'll talk about effective resistance. Okay, when do we say resistors are in parallel? Or when do we say resistors are in series? If you are talking of resistors in parallel, for example, we have this circuit. One can say that R1, R2, and R3 are in parallel. Why am I saying that they are in parallel? For resistors to be in parallel, the voltage across them must be the same. So if this voltage here is V, it means the voltage across R1 is V. The voltage across R2 is also V. The voltage across R3 is also V. So the voltage across each component on the power side is the same. So if the voltages are the same, it means if their values are different, the current that goes through them will differ. So if this produces a current, all this can be considered as one load. So the current is going to split into three. One will be I1, one will be I2, one will be I3. But they are all coming from this I, which was coming from the voltage source. So the voltage source was split. So one way of identifying that resistors are in parallel is there is current splitting or current coming together. That's a way to see that they are in parallel. Okay, so this is for parallel connection. And for series, for resistance in series, you will see that there is the same amount of current going through the two or three resistors. So assuming we have R1 and R2, and there is I that started from this voltage source V is the same thing that will pass through R1 and the same thing will pass through R2. So at the end, we will see that the current that moves through R1 is the same current that moves through R2. So this is a way to check if it is in series or it is in parallel. So they can give you a circuit like this. Then they will tell you that what is the relationship between this is R1, R2, R3, and R4. What can we see over here? We can clearly see that the current that started moving from R1, it will get here, it will split. So if it is I, we will get I1 and I2. But then I1 is the same thing that is going to pass through this R3. So what are you going to get? You will get that R4 and R3 are in series. Why are they in series? They are in series because the same amount of current goes through them. So they can give you circuit to calculate the effective resistance. But to calculate the effective resistance, you must first identify, are they in series? Are they in parallel? If they are in series, what should you do? If they are in parallel, what should you do? If they are in series and you want the total resistance, it is just the sum of the resistors in series. So if you have n resistors in series the RT is going to be R1 plus R2 plus R3 plus LF plus Rn. But if it is parallel and there are n number of resistors in parallel, to get your RT is going to be, or your RT cannot be found straightforward, but it is done by using 1 over RT is equal to 1 over R1 plus 1 over R2 plus ellipsis plus 1 over Rn. After you reciprocate to get your RT. So this is how to find the total resistance if resist more than 2 resistors are in what? Parallel. And this is how to find the total resistance when n number of resistors are in series. So now that we have this formulas, we will try by solving this example. Let's solve these two examples. So to solve the first example, we will redraw the circuit diagram. We have a resistor here. We have resistor here. We have resistor coming across. Then we have a resistor here. So to find the total resistance, first do current division. Look at the places where current is going to pass. If you know where the current is going to pass, you will identify whether there is short circuit or open circuit anyway. If there is no short circuit, then your work becomes easy. If there is no open circuit, it's easy. But if there is some and you forget, you might mess up your work. So you always do the flow of the current. So current will start moving from here. It will get here, it will split. So if it is I, it will split into I1 and I2. It will get here, another node. It will split I3 and I4. Then they will come together again here. Then the circuit continues. So we can clearly see that there is no short circuit. So if there is no short circuit, then you come and check this and this, are they in series? No, they are not in series. Why? Because I4 is going through this 6 ohm resistor and I3 is going through this 4 ohm resistor. So there are different currents moving through this and this. So we will start by finding your RT1. Your RT1 will be between these two. And between these two, you can see that there is a parallel connection. So 4 ohm and 6 ohm are in parallel connection. So if they are in parallel connection, to get the effective resistance, which is RT1, you write 1 over RT1 is equal to 1 over 6 plus 1 over 4. And this is going to give you 5 over 12. That is when you do it on the calculator. So you have 1 over RT1. So your RT1 is going to be, you reciprocate. So you get 1 over 5, which is 2.4 ohms. So after getting 2.4 ohms, what can you do again? Now this circuit, you can redraw. If you redraw now, these two resistors are meant to form one resistor, which is our RT1. So you have this. This is now 3. Then we have 2 ohms. Then these two are merged. So since they merge, you represent them with one resistor, which is now our RT1. So now you can see that RT1 and 2 ohm are in series. Since they are in series, we are going to find RT2. And RT2 is just talking about these two. They are effective. And since they are in series, we can clearly see that we will just add them from the formula for the series I wrote. So you have 2 plus 2.4 ohm, which is going to end up giving us 4.4 ohms. So after getting 4.4 ohms, now these two have been merged. We are going to merge these two. So if we are to merge those two, we are going to end up getting a final circuit like this. Now this is our RT2 and this is our 3. Now what are you seeing? You are seeing that they are in parallel. So if they are in parallel, how do you find the effective resistance? To get the effective resistance, which is now our RT, 2 turns in parallel, you get 1 over RT is equal to 1 over 3 plus 1 over 4.4. And 1 over 4.4 plus 1 over 3, I think if you do turns right, you get 1 over RT. So you get 1 over RT being equal to 37 over 66. So therefore, RT is equal to 66 over 37 ohms. So this small circuit that they gave us, you see what we have to go through just because of series and parallel connection. Someone may ask, so is it really necessary for us to rate roll? Me, to my advice to you, I will always advise you to rate roll, because when you rate roll, you'll be able to take those two things that you made them and represent it with only one resistor. Like initially, how many resistors were there? 1, 2, 3, 4. They were 4. But after merging these two using power connection, and we have the 2.4, we saw that I represented it with RT, which led to 3 resistors now. And those 3 resistors, I just clean this one and put the 3.4, their total resistance here. After that, these two are now in series. After calculating for their total resistance, you just merge them to form one resistor, like I have here. Then you are down to 2. If you are down to 2, now you can easily get the final answer. They are in parallel. You indicate power connection, and for power connection, you know that it's 1 over RT is equal to 1 over R1, and our R1 here is 3, plus our R2 is RT2, and RT2 is that. So if you punch everything on the calculator, this is what you are getting. With the second example, you can, after watching the video, you can try the answer on this. Our next lesson, when I come, I will give you the answer to this question. There you go.